Hello, everyone.
Wow, wow! It's always hard to transition from rock music uh, to just voice like that. Hello, welcome to the very first Swift server meetup. Or your host tonight will be Joannis and myself. Hello, Joannis. You're based in
Hello.
Amsterdam,
I'm based in Eindhoven, the Netherlands,
Eindhoven.
and yeah, we're both members of the Swift Server work group. And as Sebastian already mentioned, this is the first online Swift Server meetup. There have been previous Swift Server-based meetups around Vapor and other frameworks, but this is the first one organized by the Swift Server work group itself, of which we're both a member. Um, today's agenda is yeah.
Eh,
Today's agenda, there are two talks, one by Jim Schultz, an iOS engineer at Vulcan, who's going to talk about using Swift on portable Linux devices, after which Tim Condon will be focused on demonstrating Vapor server-side Swift with Vapor. Tim is also a member of the Swift server workgroup and is part of the core team of Vapor. After that, we'll be hosting a Q&A, ask us anything about the Swift server workgroup, anything server Swift related you can ask.
and we will try to answer that. We have other member from the working group that will join us for that Q&A session. I see that Sven is already there in the backstage. If you don't know what is the Swift server working group, it's a steering team that promotes the usage of Swift on the server. We are meeting twice per month. Our meetings, notes, and minutes are available on the Swift forum. So I invite you to join us on the forum there. You can see the different projects that are in progress. You can contribute as well. And talking about contribution, we want to make this meetup a regular event, like every 3 months, every quarter to get started. So if you have a Swift application running on the server side, if you have a hobby project, if you are contributing to a library, let us know, contact us on the forum. We'll be happy to have you as a speaker in one of the future meetup there. Before starting, I also would like to encourage you to say hello on the chat. Many of you did that already, but tell us where you are. I love to see all these names. So currently, I saw Tempe in Arizona, Munich in Germany, Cupertino. I saw Hi from Brazil. I saw Ola from Austria, from Pakistan, from the Netherlands, from Burbank, close to Los Angeles. What else? From Denver, from Toronto in Canada, Ohio. So it's truly
Winnipeg.
international. Um, Truly international, truly global crowd. Oh, someone from China. It's really late there. Sorry for that. We'll try to alternate also the time for this meetup. One more thing before we start with our first speaker. This meetup is recorded, obviously, so it will be available on YouTube forever. We'll share the link, so do not hesitate to talk about this meetup to your colleagues and to be even more. We are almost 100 right now watching the live stream, so thank you for that. And let's grow this community. Janice, back to you to introduce our first speaker for tonight.
So tonight, our first speaker is Jim Schultz. Jim Schultz is an iOS engineer at Vulcan, but has been doing some really interesting Swift server work on Linux. I can explain this in depth, but I think it's best for himself. Here's Jim Schultz.
All righty, how's everybody doing? As I said, I'm Jim Schultz. I'm a software engineer at Vulcan. To tell you a little bit about Vulcan, we're based in Austin, Texas, founded in 2020. We produce electric UTVs, motorcycles, and e-bikes. You can see the nice little picture there, some of our products. A little bit about me. I've been doing iOS, Apple software development roughly 15 years or so. A few highlights from things I've worked on. My very first app I worked on was called Calbetica. It was a third-party calendar app. At the time, that was a big deal. But anyway, First Opinion was another. It was like a text your doctor type app. I worked on Strong Lifts. It's a strength training app. I worked for USAA, Walmart, dozens and dozens of side projects I've done on my own as well. As you can see there, I'm also father of 4 very rambunctious kids, got lots and lots going on in the evenings and mornings, and there's always a hustle and bustle going on. And one of the things I wanted to talk about a little bit, just a little self-promotion, is a side project I work on called Whiteboard. It's a kind of a kid-focused drawing app. No distractions, just kind of pure drawing. Very, very simple, easy to use. Put a lot of thought and effort into making it a screen-friendly sort of creativity boosting app. Just a few highlights and from drawings my kids have done. We've got Wonder Woman here, really sort of basic drawing, but they love it, and they'll spend hours and hours on this thing. So just wanted to give a shout out to my own little app here. So moving back into Vulcan, I've been with Vulcan for not quite 3 years. I started out working on the iOS applications, and about a year in, I was asked to lead our 2-wheel projects, our motorcycles and e-bikes, for the digital team. And for the last year or so, I've been leading the digital products team. Digital products, we are responsible for all the in-vehicle human-machine interfaces, all our mobile applications. We've got consumer apps. We've got some internal applications for doing diagnostics, and we have a mobile app on our assembly line, and then a couple partnership apps with a couple different partners we work with. Just a couple highlights from our consumer app. We've kind of devised a little system. It's not super novel, but try to make it as simple as possible to connect to your vehicle. You scan a QR code, and that tells the app exactly what it needs to do to connect to your bike or your vehicle. And every time thereafter, it automatically reconnects. There's no big list you have to sort through or any of that to connect over Bluetooth. It just kind of works all the time. The mobile app allows you to adjust various vehicle parameters on the vehicles, adjusting performance characteristics and things like that, do firmware updates, and see vehicle diagnostics, things of that nature. Before I move on to what we've been working on lately with our latest project, I just wanted to give massive kudos to Giannis and the Unbeatable software team. They've been instrumental in helping us put together some pretty interesting products over the last 6 or 8 months, and just want to give them a shout out. And if you're just give them a thought for your next software project. So just wanted to show just a short little clip of sort of the in-vehicle experience here, if it'll work. This is, as you can see here, this is the in-vehicle gauge set that our team's responsible for. This is out of our test ranch. And the rest of the presentation, it all the things we've developed sort of all go to support this in-vehicle experience and also out-of-vehicle experience. We've kind of built up an ecosystem of technologies all interconnected that we hope help make the customer experience more enjoyable. Just some of the platforms we're using Swift on, Of course, we've got mobile applications. We've also got a backend server, and then we've also added Swift to some portable Linux devices on our assembly line. We'll be talking about each one of those. Oops. Excuse me. There we go. Just to give some context here on our assembly line, there's a number of tasks that need to be performed by the operators as the vehicle is being assembled. There's they're taking components and adding it to the vehicle. As those components are added to the vehicle, there's serial numbers and other complex values that need to be read and stored for future use. And those are typically in the form of a QR code or a barcode or a matrix or some other machine readable code. Those need to be assigned to the correct vehicle. We got to make sure that there's no mistakes in reading and storing those values. So there's a lot of validations that are done as we're reading those values. And again, this is an assembly line environment, so whatever these tasks need to be done in an understandable, easy to use way that's not going to hold up production. So we've come up with a few things to help with this. We felt like a mobile app was a natural choice, given that the device is handheld and mobile. You're walking around the vehicle. You need to be able to move around. Phones and iPads and things, they come with camera, and there's lots of good optical recognition vision APIs for barcode, QR code scanning. They've also got network access, and there's a familiarity with mobile devices. They've become so ubiquitous, everyone's using them. So, and then as far as the UI goes, we're keeping it very simple, making heavy uses of colors and symbols to communicate quickly at a glance, whether there's success or failure or something in progress. Another reason we decided to go with the mobile app was it was fairly trivial to localize it to wherever and whatever local language was being used on the assembly line. This is just a quick little screenshot showing some of the basic UI there as the components are scanned. Assuming it's correct and successful, that block turns green. This mobile app also connects to our backend server. That's where all our vehicle information is collected and stored by our assembly line application. The backend server also does a number of tasks ahead of time, such as generating the VIN for the vehicle and other vehicle properties. It's really important that there's no mistakes, it's formatted correctly, and there's a number of other requirements that have to be error-free. And a lot of these are very easy to get wrong if you're trying to do it by hand. The technologies we're employing with our backend servers, we're using Swift and Vapor. We're heavily using an open API generator that ties our backend, our mobile app, our assembly Pi is what I call it, but it's a portable Linux device. All of those platforms make heavy use of a shared library. Our data is stored in MongoDB, and we're hosting with AWS Lambdas. So kind of recapping, our mobile app scans those vehicle data. It's then communicated with our backend server. We do a vehicle lookup. Each vehicle has its own unique QR code as well. And then those components are associated with that vehicle when you scan them. and stored in the database. Moving back to the assembly line, there's some other tasks that need to be performed on the assembly line, one of which is installing firmware on our hardware modules. It's very important that the correct version is done. Some of these can take a bit of time, so they need to be able to kick that process off and go do other things and then come back to it. There's also a number of configuration tasks that need to be done on the vehicle. There's unique things about each vehicle that need to be done correctly, again, with it error-free. And so making mistakes there's potential to break vehicles if some of these tasks are done incorrectly. So it's very important that it's done sort of in an automated fashion. So we've leveraged Swift on portable Linux. In this example, we've developed a portable device using mostly off-the-shelf components that we're using to perform these tasks. Again, it's in a assembly line environment, so it's got to be simple, easy to understand, quick. We can't hold up production. So again, we're leveraging Raspberry Pi at the moment. We're using Linux on Raspberry Pi. That device, again, I call it the assembly Pi, but it connects directly to the vehicle, and then our assembly app connects to the assembly Pi wirelessly. We've got a QR code that's displayed on the that device's display. They're able to scan that QR code with the mobile application. That application, again, it's able to call our backend server, pull all the vehicle specific data it needs to configure that specific vehicle, packages it up in the correct format, and then it sends it over to this device. This device then knows how to send the proper commands in the proper order to the vehicle. And at the end of that process, that vehicle is then ready to drive and be delivered to customers. Some of the technologies that we're using on this device, of course, Swift and Swift Neo. We're again also using OpenAPI. We're utilizing Docker, Vapor, and we've developed a custom driver for the display. And then Swift, as you know, has very good interoperability with the C, and so we were able to use the display manufacturer's C library for accessing the display pins. Just a brief note, the display, we try to keep the interface very, very simple, very glanceable, and in a assembly line environment, a common sort of design language are lights with like red, green, orange, blue sort of colors to communicate status of things. So we kind of went with that same theme. QR code, it means it's ready and connectable. Blue, it's working. Green is success, and red is failure. So why all the Swift on all this, I guess, is where we're at now. There's a whole lot of other things that could be used, but for my specific use case, it was important that my team be able to maintain it. At one point in time, we're as many as 10 engineers on the digital products team, but I don't know if you've noticed or not, but the EV market's taken a pretty big hit the last couple of years. And anyway, our team is pretty small at the moment. We're down to 2 engineers. We were able to rely on, again, Giannis's team at Unbeatable for their help to do a lot of this. Some other benefits I saw was we were able to share a lot of code between all those platforms. Using OpenAPI generator was pivotal. And again, you've got a common development environment for all of those. There's just so many little things that add up that made it a really natural choice for me. So some common arguments I've personally heard about using Swift on lots of platforms are this concept of Maslow's hammer. I don't know if you've heard of that or not, but it's this concept that if you have a hammer, everything looks like a nail. And it's sort of a bias to use familiar tools, which, depending on how you look at it, can limit the solutions considered. Obviously, this is a sort of a pun, cheesy joke here, but we're talking about this type of nail. So it's this idea that, you know, you're familiar with the tool, so you just use that tool for everything you do. And I guess I'd say that's true. Like, and I don't necessarily see that as a bad thing. I wouldn't dispute that. Using a common or a tool I'm familiar with is what I'm doing here, and I think there's some nuance to Maslow's hammer that may be important to consider. When I think about it, I think, well, what if everything you're working on is a nail, and isn't using what you have a lot of times preferred anyway, especially when you're just starting out. And in terms of limiting yourself, most of the projects I've worked on in my career already have significant limits from the beginning, and are quite constrained right out of the gate. So you can't really consider all options anyway. So in my mind, you know, you've got nails of all shapes and sizes, but they're still all just nails. And you got to start somewhere, so you might as well start with the hammer that you've got. They're all still all the nails are still nailable, right? With the hammer that you've got. So I guess my suggestion is that Maslow's hammer isn't necessarily a vice, but it can be a virtue if you look at it right. And it's my opinion that Swift is an especially adept tool at multi-platform use, and ultimately we're just creating software, and Swift is great at creating software in lots of places. Using Swift on multiple platforms at Vulcan really enabled around 1 to 3 engineers over the course of 6 to 8 months to build what I've just described. Had we had to use multiple languages and frameworks, I'm not personally sure we could have delivered those solutions for the budget or the time that we had. In my mind, adding more would potentially have been a premature optimization or over engineering out of the gate. And one of the benefits I see in using Swift on all these platforms is you have this pool of people to choose from, and it allows you to allocate those same people around to each platform or wherever the demand currently is. You don't have to bring on more people. It is true that you can get a specialized hammer for each job you have, but you also just need to have a good all-around hammer for your tool belt. Again, I believe that Swift is a great all-around tool to have in your tool belt, especially if you already know it. Why not use it for more platforms? And if you do get to the point where you need something more, that's a good thing in my mind. It means what you're doing is working, and maybe it's time to just go add another tool to your toolbox. You're prepared for it and can take that on. I I think it's important to resist the urge to grow too soon. Every time you grow, it just adds so many more little things, complexities. Your communication and coordination needs increase. There's so many peripheral type things that come on when you're growing that can really affect your productivity. And I think it's also important to remember that yes, there's this urge to always go after the biggest, best, strongest, faster thing. There's always going to be something bigger, better, faster, stronger. Um, but the reality is there is no perfect tool, language, or framework. And especially again, as you're starting out, just use what you have, get it working, solve for the 80% solution. Once you've proven that out, then start optimizing for that last 10%. One last thought I'd leave on all this is sometimes it's important to just do things because you can. Just a little background on this picture. This is a painting that I had this guy on Instagram. He does these really funny sort of mashup type art, and I reached out to him and had him do a painting of Thor on a grunt for us. The grunt is the name of our motorcycle. This painting is based on Thor's fight with the giants. It's a kind of a famous painting of Thor, and I think there's a lot of really great things out there that exist simply because somebody woke up and decided to just go out and do it because they could. And what might seem like perhaps an odd choice can turn out to be pretty epic in the end, but you got to make the effort to do it. And then if you remember Thor, he had a hammer as well called Mjolnir, and perhaps in the right hands, Maslow's hammer can look a little bit more like Thor's hammer, and you can do some pretty amazing things with it. So that's really all I had for my presentation. If you'd like to get a hold of me, here's my contact information for Vulcan related things. If you want to reach out personally or on LinkedIn, there's my info, and I'll sign it back over to Johannes.
Thank you, Jim. We had a lot of questions and a lot of discussion in the chat while you were speaking about the frameworks, the tool you were using, some questions about architecture and how to share code between the client and the backend. So I'll try to take them and put the question in the order they appear. Some of them are probably just a yes, no, or they've been answered later in your talk. The very first one that came was from the Dream Rep. Do you use Swift in the electric vehicle as well?
Okay, that's at the moment, no, we did not. We're it's more C++. Mm-hmm. That is something that we've been considering.
Are you using Swift embedded?
So on the no, on the Raspberry Pi, that's probably the closest that we're not using it yet. No. Some of this lean on Johannes as well to help with specific answers, but yeah, we can keep going.
Yeah, do you want me to answer that, Jim? The embedded thing?
Sure. Yeah.
So we've been, I've been involved with the Vulcan project, of course, and we've been looking into embedded Swift as well. We have a couple prototypes or like not complete prototypes of hardware, but we have some small initial work investigating into how we can best apply Swift embedded at Vulcan to save time and resources as well, because we're a small team that are trying to achieve a lot. And one of the things that we've been looking into is looking at setting up protobuf or some shared protocol implementation to have your phone and your vehicles communicating with one another to lower the friction when when these systems need to communicate, and the debugging experience will require one developer that knows Swift instead of the embedded engineer and the iOS engineer and whoever else is involved with the different devices. So this is kind of what we're looking into for Vulcan, but I don't think realistically that it will be all Swift, but I do think there will be Swift component. There is a possibility for Swift components down the line, just as a mixed language approach.
Yeah, what I'd add to that is just that we're just kind of getting started on a lot of this. There's so much more that we want to do. We just had to kind of start somewhere, and there's a lot of potential use for Swift in a lot of places.
Yeah.
Next question is from Michaela Caron, and there was a lot of discussion back and forth in the chat about that one. What's the best way to share models between the iOS app and the server, the Vapor server? Do you create a Swift package with just a codable model or just data transfer objects?
Yeah, I can. I'll attempt to answer most of that, and then defer to Ioannis as well. Again, we're using Open API generator for a lot of this, and then we do have a shared package that is shared between all the platforms.
That was a question as well. Which Open API generator are you using? I was assuming, and I post the link in the chat, that you use the one from the GitHub open source project on Swift server. Is it correct?
Yeah, I believe that's the one we're using. Yeah.
Yep.
I think this one has been answered during your talk as well. What is the underlying backend infra for Vapor? But you answer it's Vapor on AWS Lambda.
Correct. Yeah.
Correct. I'm scrolling through all the comments to find the questions. Maybe you have one.
Michaela had one more that's asked, do we use VS Code or Xcode?
Yes.
So what do you use, Jim? VS Code or Xcode?
Oh, we're actually using VS Code quite a bit. We still can't completely get away from Xcode, so we're using both. Yeah. But they're both really great tools.
I'm kind of expanding on this because I have insider knowledge, of course. We're using dev containers a lot to keep our development environments in sync, especially when we're working with the portable Linux devices, which we like to emulate on our host macOS. We want to keep macOS and Linux in sync as much as possible so we can more rapidly prototype. What's your experience been with VS Code dev containers?
What has my experience been?
Yes, yours. Yeah.
I mean, it works great. Yeah, I haven't had really any problems.
Yeah, there was the same type of question from Brandon, mentioning Vim as well, which is a perfectly viable alternative as well. I think we're gone with all the questions. Do you have any more, Janice?
I see one by Jesse Zamora. That asked, how many Swift applications are you running on the Raspberry Pi? How is the startup performance?
Ah, yes, this one.
I can attempt to answer some of this. So we're using Ubuntu Core, which is kind of one of the how would you describe that, Ioannis? Just it's like the most basic version of Ubuntu.
Yeah, it's a very slim installation. It's very like we're not touching much about the installation. Of course, you can't with Ubuntu Core, so this keeps us from breaking things in updates.
Yeah, and then we're running Vapor, Swift Neo. What else am I missing?
Yeah, we're using Docker first of all,
Yeah.
I guess.
Mm-hmm.
Yeah, so we're using Docker. We're currently looking at startup performance as well, because Docker is pretty heavy for the Raspberry Pi that we initially started using, which is the 0, if I believe.
Yeah.
That it? Yeah. So the 0 is the one that. Can I grab it from stream?
Sure.
It's right over there. So we have I have a prototype as well that we soldered. So this is a 0 with this, which is a bit more lightweight than what Jim showed in his presentation, and the startup performance of this is not great. This doesn't have a battery attached yet, so it would help if it was already awake for a bit. But yeah, it's not the best. So a lighter runtime might help, but the bigger Raspberry Pis are very capable and aren't a problem at all. I don't think. Yeah, there it is. Yeah.
The zeros do work. I mean, that's what we're currently using. We haven't switched.
Like memory usage is fine. We don't need much for Swift at all.
Yeah.
And there is Rick and Michaela that would like you to dive a bit more into dev containers. I don't know, Jim or Janice, if you can explain a bit more what it is and how you're using them.
Yeah, go for it, Jonas. You can give the best on how.
So, normally when you have a new machine, and that can be any machine, right? Linux, Mac, Windows. When you have a new machine and you want to start developing an application within language that you haven't used before, or maybe with a different set of language versions, there's this whole setup procedure that you need to go through. You need to get the right toolchain version, update it if need be. You need to download some dependencies, C libraries, for example, or whatever. Now, Swift Package Manager already relieves some of that because you can bundle some C code with your Swift packages, but then you need to compile those. But oftentimes you need system libraries to be in sync, and there's just so many environment things that need to be right across all devices of your developers. Now, if I add a new package and Jim doesn't have that package, I need to document it and educate him that this is what's going on. And that's a very painful experience when you're rapidly iterating with different versions of tool chains, when there's a new Swift version coming out that you're depending on new features for. It's just a hassle when you're iterating quickly sometimes. You can, of course, work around it with good documentation and communication, but like Jim mentioned previously, it's all about trying to stay lean and trying to steer away from things that might break or cause unexpected hiccups in the development process. So we use a Swift dev container. This is a Docker container with a Docker file that sets up your environment just as a file. It's basically a script an installer script for a new machine. And we use a Swift base image that is just the same Swift image that you would use in the cloud. But instead, we run it as a local Docker container and modify it with our extra development environment requirements like library X. Maybe we use SwiftLint, for example. All of those tools are installed in the dev container. The only things a developer needs are VS Code and Docker running, and they can press one button and it will compile all of the dependencies, set everything up, and then they're just ready to go.
Yeah, it really is really slick. It works so well. It's worth probably doing another presentation sometime.
Mm-hmm.
Yeah,
that's probably a subject for one of the next meetup. There is a question from Nathan about caching Vapor dependencies, but I'd like to keep that one for Tim and the Vapor talk just after. Maybe a last one before handing over to the second presentation today. When we talk about startup time on the Raspberry, are you talking about the Swift runtime, the Swift program, or the overall startup time?
I was talking about the overall startup time, but a lot of the time spent that I measured was not the Docker container; it was a Docker runtime. The Raspberry Pi also, like the OS needs to boot up. It's an SD card in there, and they're not always the fastest. I do have a fast one, but even still, I think most of the time is spent with disk I/O and the Docker runtime.
And the second part of the question: have you profiled where the startup time is being spent?
Yeah, I didn't go too much in depth, but like I measured most of the time spent in disk I/O loading files of the disk to boot the OS, to boot the container, stuff like that. And the Docker runtime is by far the heaviest on this Pi, on this one. But I'm not sure. I haven't profiled on Jim's one, of course.
Some of this can just be resolved with better hardware, but we had to start somewhere, and we needed a solution that was easy to come by and relatively inexpensive, and just kind of off-the-shelf components that were easy to swap out if needed.
Yeah.
Thank you, Jim, for this inspiring talk. Janice for the Q&A as well, and it's our pleasure to welcome our second speaker on stage today. Yes, it's you, Tim. You're muted right now, so you can unmute and share your screen as well if you have a couple of slides for us. So Tim is the organizer of the Swift Server conference in London and one of the project maintainer for Vapor, which is the subject of the second talk. The stage is yours, Tim.
Thank you very much. Hello, everyone. So for the kind of first meetup, we thought we'd go back to kind of a bit of a basic talk, a bit of a getting started talk. For those of you who haven't seen any server-side Swift before or just interested in it. But I've got plenty of time for questions at the end, and I'll try and throw in some interesting stuff as we go along for those who have seen it before. So as mentioned, I'm Tim. I run a company called Broken Hands, and we do server-side Swift training and consultancy and work with clients literally all over the world in many, many different time zones, but helping them deploy Swift on the server. I'm one half of the Vapor core team. So we're responsible for building and maintaining and evolving the framework, whether that's fixing bugs or implementing new features or even looking forward to Vapor 5. I sit on the Swift server work group, which has been well explained now. And I also sit on the website work group as well, which is responsible for Swift.org and making sure that that works and is as good a community entry point as it can be. So we're responsible for new designs and updating the content and stuff like that. I'm also part of the server-side Swift team at CodeDeco, so there's lots of tutorials and stuff on there. And if you have any questions, you can ping me after this. If something comes up that you haven't remembered to ask, just feel free to reach out on pretty much most of the social media and Slack and Discord as 0x10. And I organize a couple of meetups and the server-side.swift conference, which is a conference focused solely on server-side Swift. And there's some bits about it in here, but tickets are on sale for this year. It'll be in London in September, and it is the one place where everyone comes together to talk about server-side Swift. So for those of you who've never heard of Vapor or aren't really sure what it is, Vapor is a framework for building applications, backends, APIs, web apps, even command line applications on Linux using Swift. So it provides pretty much everything that you need to build any kind of application for handling requests. It has a number of different modules. So there's a module called Fluent, which is our ORM or our database abstraction layer, and that makes it very easy to interact with databases. We can obviously send and receive HTTP requests, otherwise it would not be a great web framework. And there's various other modules. There's a module called Leaf, which does templating, which is used pretty extensively for email generation, for generating HTML emails, and is also used for front-end stuff as well. So in Vapor, we have about 60 repositories that make up all the different parts and the project, which we maintain. So there's quite a lot going on there. But all of these parts come together to allow you to build great applications. So Vapor was created back in 2016, so it's getting on quite a bit now in terms of the server-side Swift world and the server world. But it's created by a guy called Tanner Nelson, and then Logan Wright joined pretty soon after. And they shepherded it through a number of different versions. And then I joined the core team back in 2021, and have been there ever since. It's built on top of Swift Neo. So we've heard lots of things about Swift Neo today, but it is a non-blocking IO event-driven framework provided by Apple, and it does all of the heavy lifting for interacting with the kernel, parsing HTTP requests, all the kind of gnarly stuff that we don't really want to do, that allows us to build a really nice API for you to use to build your applications. Vapor has always been a Swift server framework for Swift developers, written by Swift developers. It has a very nice Swift-like API. It's very easy to use. And as we adopt more and more features like Swift concurrency, the transition or the context switching required to go from, say, iOS to the back end becomes a lot less because it's just Swift. And so we make use of a lot of Swift features to make it really feel like a Swift API. And Vapor has an awesome community. So we have a great Discord channel. There's lots of people in forums, and lots of people at talks and stuff. So if you have questions, feel free to jump onto Discord and just ask, because you'll get lots of people helping you. So why would you pick Vapor? And these slides about why you'd pick Vapor will apply to any Swift framework as well. So they apply to Hummingbird, they apply to Smoke, but it's why would you use Swift and Vapor on the back end? Well, the first one is you get happier developers. Now, what do I mean by that? So if you're a developer building an iOS application, for instance, or a backend, at some point you're going to need some kind of backend. So at some point you'll be building your iOS app, and then you need, how do I kind of sync some data up? How do I store this data so that my users can log in different applications? Pretty much every app these days needs some kind of backend. So when you're first starting off, you might use something like CloudKit. And CloudKit is really good. It's very easy to use. It's very quick to get started with, and it's nice to use. So on this very scientific graph I have here, which has developer happiness on the y-axis and functionality on the x-axis, you can see that it's easy to use and it makes you happy. But the functionality provided by CloudKit isn't great. There's not a lot you can do with it if you really need to start doing custom stuff. So as time goes on and you build your application and it gets more and more complex, you realize you need a bit more functionality. So you might choose something like Firebase. Now, Firebase has a lot more functionality, but your developer happiness drops because you end up starting to duplicate business logic, because you have to, if you have an iOS and an Android app, you have to duplicate the code that sits in both. And it's still quite constrained of what you can do. So eventually you realize you need a proper backend, you need a full feature backend. And so you might pick something like Node.js, or it could be Laravel, or it could be Ruby on Rails. And these provide all the functionality you'll ever need to write any kind of API or backend. But your developer happiness is way down because you're using a language that you don't know, that you have to context switch, that you have to learn, or that isn't very good. A lot of these legacy languages, as I like to call them, have significant flaws with running backends. They're great and they have their experiences and their massive communities, but it's very easy to make mistakes. And Swift provides a large number of benefits, which we'll get into. So eventually you realize, well, actually, why not I just use Vapor or Swift on the back end? Because you get all the functionality that you get with anything else, and your developer happiness goes way up because you're using Swift. So you get happier developers. You get a compiler, and this will blow people's minds who come from interpretive languages, but you can have a compiler tell you that your code has errors before you ship it to production. And I say that not entirely in jest, because it is a real fact. As Swift marches towards Swift 6 and we see more adoption of things like Sendable, the compiler can really catch a load of errors up front, which means that the code you actually ship has a lot less errors than it would normally do. So things like null pointer exceptions just aren't possible in Swift. Things like data races won't be possible with Swift 6. So all these kind of classes of errors that you get with other languages just simply are not possible because your code will not compile. And this is a really powerful feature of Swift that we need to emphasize as a work group and sell as a real unique selling point of Swift on the server. If you're coming from iOS, you get to use the same tooling. So you get to use Swift, you get to use Xcode, you get to use all of the stuff that you already know. You get debugging support as well. So you can just put a breakpoint in your request handler and stop and inspect the request, which is really powerful to be able to do that with LLDB. And all these features work in VS Code as well. If you're a business, why would you choose Vapor? Well, it comes down to money, like everything else. Swift on the server is very efficient. Swift Neo allows us to write completely non-blocking packages and database drivers, which means that we can handle more requests per second than you would traditionally be able to do. So you need less servers. But Swift's real selling point is its memory usage. So a typical Swift application has around 6 megabytes or so, 6 to 10 megabytes, that kind of order of magnitude. And this can handle thousands and thousands of requests a second. There was a really interesting graph from one of the people who use Vapor recently when they hit a memory issue with JWT kit that we fixed, showing their memory usage hovering around like 8 or 9 megabytes whilst they're handling thousands of requests a second. And this is significant differences compared to PHP or JavaScript or any kind of interpreted language, even Java, which has a JVM. And because you need less memory, you need less servers. And I've worked with clients in the past who've seen their infrastructure bills drop by like 85, 90% because they don't need so much memory. So thousands of pounds to like $20 a month, purely because Swift is much, much more efficient. And it's much safer because your code's going to be safer because you have the compiler. It's going to crash less, which means your users are going to be happier, your customers are going to be happier, and it makes for a better experience. So if you want to deploy Swift on the server, it's very easy. It supports Ubuntu, CentOS, Amazon Linux, and I think that might be it officially now. But essentially, any kind of Linux environment works. It also supports Heroku and Fly.io. Those are two really good deployment sites for getting up and running quickly, but it also supports Docker. And because you can run it in Docker, you can run it pretty much anywhere. So if you're already using Kubernetes, you can just deploy it as another pod. And any modern hosting solution these days will support Docker. So just to clear up any confusion, as the last year that I will ever show this slide, if you were asking, is it ready for production? Yes, it is. There are plenty of people, as we've just heard, using Swift in production for real things, and it works very, very well. As we kind of march towards Swift 6 and Vapor 5 and the next version of Swift Neo, we're really building on a kind of battle-tested modern stack that's really been through a lot of eyes and a lot of testing and a lot of experience. The SSWG have done a really good job over the last couple of years of building a great ecosystem to the point now where there are packages for most things. It's very rare that I'm working with clients, developers and client teams where there isn't a package to do what they need for some kind of API or some kind of thing. So most of the ecosystem is there. We just probably need to do a better job of selling it. We support all the things you'd expect for observability, including metrics and tracing and logging. OpenAPI over the last year or two has seen great strides with the OpenAPI generator. So you can go from an OpenAPI spec to roots, or you can go from roots to OpenAPI specs. It works both ways now as well. We have lots of database drivers for MySQL and Postgres and SQLite and MongoDB and DynamoDB. There's an Oracle one being worked on at the moment. So we cover pretty much all the bases there. And async await has made a really big difference. So the learning curve to getting started with Swift on the server now, since Swift concurrency landed, is really been lowered because it just uses Swift concurrency. There's no need to learn what a future is and what a promise is and the difference between a map and a flat map and a tri-flat map, a flat map throwing. It all just kind of works. And the community is really good at solving issues. So this was a problem that came up a couple of years ago. There was a memory leak in a Vapor application, and we saw people from all across the community getting together to solve a pretty horrible low-level bug. As a nice shameless plug, if you go to the server-side Swift website, there are videos from the last few years of the conference of people talking about really interesting use cases, companies that have seen great performance benefits and startup times from going to Swift, and different companies using it and success stories. So I highly recommend checking those out. And some of the companies that use Swift on the server, Mercedes-Benz use it, sort of their dealership kind of kiosk stuff, the back end, so the iPads that they walk around with, that uses Swift on the server in the back end. ING Bank and Fin are two clients who use Swift on the server and process actual monetary transactions with it because they trust it. Nodes is an old agency that had lots of clients running Swift on the server. Allegro is a very large e-commerce site in Eastern Europe, kind of like Poland's Amazon, and they use a lot of stuff for image processing and interacting with C libraries. Amazon, if you've ever watched anything on Prime Video, that's gone through Swift on the server. The BBC use it, as do companies like John Lewis in the UK. And obviously Apple use it. So they have at least publicly confirmed that quite a bit of stuff is now using Swift on the server, which is great to see. It is really there and being used in production for real things. Okay, so I'm going to jump out of here and then try and share my whole screen. On there.
You're going to show us a demo.
I'm going to do a live demo.
Yeah,
it's much more
live
interesting
coding.
than me talk.
Yeah.
So hopefully my screen is on. There we go. Cool. And that's very small. So let's increase that. Okay, so Vapor comes with a command line application called the Vapor Toolbox, and this allows you to create projects very easily. So you can just do Vapor New, and then I'll call it Hello Vapor. And this will pull down a template and then ask us, do you want to use some stuff? So we want to use Fluent because we want to do some database stuff potentially. So we say yes to that. We're going to choose SQLite because it's very easy to just get up and running without any need to run up a database server. We're not going to use Leaf. And this will generate an entire project for us that we can just go into and then open up the package.swift. Let's see if I can move that over there. Okay. And this is your Vapor application. Open an Xcode. You can see here you have your various packages. So you have your package.swift file, which defines all your dependencies. So we said yes to Fluent, so we pull down Fluent. We also said yes to SQLite. And this is a real application that we can just build and run. So I'll get that building now. And we have various routes. We have some configuration and then some models and migrations and controllers, which we'll go through in a sec. So you can see we have two routes here defined for a routes request. So that's a request to the top end application. So mywebsite.com, that's it. And then a request to /hello, and that just returns a string. So I'm going to write some new routes. So if I do app.get hello, and then I want to say hello to anyone who is coming to my application. So it's not very practical to write out every single name in the world. So Vapor supports dynamic path parameters. So you can do that using a colon and just say hello name. And then that takes a closure. So this bit here just tells the compiler and Vapor that this will match anything under this path. So /hello /anything will get matched here. And we just get a request in, which is an incoming request. And because we just want to return a string, we're just going to return a string. No need to make it more complicated than it needs to be. No need to write response bodies or set status codes. You can do it all for you. So I'm going to get the name from the request. So these two match, and there are ways of making this less stringly typed as well. And then I'm just going to return my message. And then let's do it, make it capitalized to make it a bit nicer. So if I build and run that, I'm going to launch a REST client. So you can see here that the server is now started because I built and run my code. This was a fresh project as well. Didn't take that long to compile. Things are getting quite nice on Apple Silicon these days. So I'm going to create a new Rapid API request. I'm going to send the request to localhost, if I can spell, localhost 1980, and that returns the route up here. If I do slash hello, it returns hello world. And if I do slash hello slash Tim, it returns hello Tim. All very easy. It also provides a lot of error handling for you as well. If I do app.get, let's say, bottles, and then we want to get the count of bottles. So I'm going to get the bottles from here. Require count, and then I'm going to say this is going to be an integer, and I can do count bottles on the wall. So if I build and run that, and then create a new request to bottles /99, or 00 would work as well. You can see I get 99 bottles on the wall. If I then try and pass something that isn't an integer, this actually returns a JSON body for you automatically. So you don't have to write any error handling code for this. The kind of default project for you from Vapor will handle all of the errors for you, return a nice error response. You can see that you get a 42 unprocessable up the top there, because it can't handle this request. So it handles all these things for you. So next I'm going to look at doing some JSON stuff. So Vapor uses a protocol called content, which is basically a wrapper around Codable. So if I define a new type called message, and I'm going to make it conform to content. Now, the reason why we require content rather than codable is so that we know what to encode the type as when we return it. So by default, it's JSON, but you can set it to be anything else you want to be, whether that's XML or form data or multi-parts, and the encoder will automatically do that for you. You can even define your own custom types, and it allows you to customize all of that for you. So I'm going to create a message, and let's go .message. And this time I'm just going to return my message. So let's do message. Hello, Jason. Oh, yes. And that's a very good point of showing you get compiler errors as well. So if I go to my Rapid API and set a request to /message, you can see I get my JSON here. I can then also put a breakpoint on the request. And you can see you get all of the data here. I can use LLDB to print out my request, which gives all the user headers, everything that's sent, which makes it very easy for debugging purposes. Handling JSON bodies is very easy in requests as well. So I'm going to send a post request to /user-info. So you notice here I'm using app.post. And the reason why I'm using app.post is because this is a post request. Previously, we've been using GET requests. So this is just a very easy way of registering a route as a post request. So there's also app.delete and app.patch and app.put, which makes it very clear when you're reading your code as to which route is doing which thing. So to get my JSON body, I need to define it. So let's define the JSON body. So I'm going to do a user info. And this is going to have a name, which is a string. This is going to have an age, which is an integer. So I'm now going to get decode the body. So user info .content .decode. So here, this user info is a guaranteed user info type by the compiler. So if it doesn't match that, you'll get an error again. But again, this just shows the power of using Swift on the server. because you have this compiler checking that the age in here is an integer, the name is a string, and they cannot be optional. They cannot be nil. Most other languages, this just isn't possible. So if I build and run that, I can then go back to my REST client, create a new request, post request to and then provide a body, which is going to be JSON with a couple of parameters, a name, which is Jim, and then an age, which we're going to set to be a number. That's going to be 99. And then you can see I get some JSON back with the message that I expected. And again, if I don't send the age, you get an error. If I send the age but send it as a string, I get an error. All these things are handled for you. Okay, so what time are we on? How long have I got left, Sebastian?
We're good. We are at roughly 30 minutes, but if you still have interesting stuff to show, go ahead, because looks like from the comment I can read, people are captivated.
Okay, let's do, I'll do one quick thing around some database interaction stuff, just to make it easier. So I'm going to define a new model. We'll do this quickly, which is going to be a reminder. Make it conform to model and content. So we need to define the schema. And then this is going to have an ID. Oops. And then a title. Spell. And then title. And then I'll explain this code in a sec. I'm going to do it for me. Okay, so this is a very simple model in Fluent. It has to be a class because we rely on reference types, and you make it conform to model, which is our protocol. And then we have it as content as well, so we can return it easily. In like a very large scale application or production application, you probably separate these out into DTOs and not do this, but for now it makes sense. So we first do is we define our schema, which I'm actually going to call reminders. And this is essentially the name of the table, so Fluent knows how to look it up. We're then going to have an ID, and this is used as an ID property wrapper, which is a special one because it's the ID. And then we're going to define our fields. So this is going to be the title, which is going to match the column name in the database. We're just going to have a title, and then we can create it. Finally, we need a migration, which is the other side. So we're going to create a reminder migration. Yeah, why not? Migration. So migration is run once and only once by Fluent, and this is what happens when you want to prepare your database. So you can use migrations to create tables, or you can use migrations to delete tables, or change fields and update fields, etc., etc. This one, we're just going to create our table, database.schema, reminders. ID, so it has an ID, and then we need a field, which is going to be a title, it's going to be a string, and it's going to be required. And then we're going to call create. So this will create our table for us. And then in the revert, so revert is run when you want to kind of undo migrations, especially if things go wrong. We're going to do database.schema, reminders again, and then .delete. So this is our migration, which will register in a sec. And in here, we're basically creating a table. So this is the same as SQL's create table, blah, blah, blah. But you'll notice that I'm not writing any SQL. So if we open up our configure file, this is where we define our configuration. And you can see here, we actually already have a migration from the template. So I'm just going to register my create reminder migration here as well. And then that should be good to go. What's wrong with you? Oh, because it's nested. Let me pull these out. Now, obviously, in a real application, you'd split this out into separate files, but time. Okay, so finally, we're going to create some quick routes to show you how to use them. So I'm going to do a thing to get all of the reminders. This is going to return an array of reminders. If I can type properly. So in this request, I want to get all of the reminders in the database. What am I doing? There we go. So normally with many other languages, you'd have to do like select star from reminders and then map the database data into a structure or type. Fluent handles all of this for you. I can just write a very quick query. .all, and this because we're now using async wait. Let's try wait. And that's literally all I need to write. And then to create it, it's going to be a post request to reminders. This is going to return the reminder once it's been created. So I'm going to get my reminder and decode it from the incoming request. And then I need to insert it into the database. So run an insert query, make sure I map the data through to SQL properly. So to do that, I just do try await reminder.create. And then I can return my reminder. And that's literally all you need to write. And you can see how expressive Swift is and how simple it is using Swift, because you can just read the code. And now we're using async await as well. It's very clear as to what's going. So we'll just demonstrate that to prove it does actually work. So I'm going to duplicate this and send a post request with my title, which is going to be prepare talk for Meetup. So one thing I should mention is that Vapor gives you control of when you run your migrations. So if you have a deployment where you have, say, 10 instances of the same app, you probably want to be in control of when you run your migrations, make sure they don't all try and run the migration at once. So I'm just going to run the migration when the app starts up, auto migrate. And this will actually go through the list of migrations and now should create the table. You can see here it started my migrations. So if I run that, you can see I get my JSON back with an ID now filled in. And then if I make a get request to reminders, that's not what I typed. I get my array of reminders back. So it's very easy to make write requests. And with things like Swift concurrency now, it's very easy to read the code. The template comes with a to-do reminder as well, which is actually very similar. And then a controller as well. So controllers are ways of splitting up your routes into separate files and make it very easy to write. So you can split them out as separate functions. Okay.
Wow. There are a few people skeptical about the fact that you're coding live. Can you type your local time in the demo right now to show it's not a video?
Yeah.
So for you, I guess it's 7:16 p.m.
It is now 19
in London.
In sunny Manchester.
Oh, in Manchester.
Believe. Okay.
Thank you, Tim. Anything else
so yeah.
before taking the question?
Nope, nothing else. Basically, where to go from here. Check out the Swift open source Slack, which has lots of great people on it, Vapor Discord, and the Server-Side Swift conference as well, which if you want to be anywhere around people who do Server-Side Swift, it is the one place to be.
We'll all be there.
Yeah, it will be great. Awesome. Right, yeah, I'm happy to take lots of questions now.
There was a question from the previous talk that I pushed back to this one about the cache of dependencies. Is there any way to improve the build times when you're deploying new versions?
Yeah, so currently things are getting better with each version of Swift. I'd say that caching dependencies, the one thing you can look at is the Swift Package Manager cache, which is in your local directory and then .swiftpm. It has a cache of all the dependencies you've ever used as your local user. So you can copy that across different build machines, so you don't have to reclone the whole of Swift Neo or whole of Vapor or anything. It will have all of them already cloned there, which is why when I first opened this project, it was very quick to resolve the dependencies because they're already there. In terms of actually building dependencies, that's still pretty much an unsolved problem in Swift. There are plans to share build artifacts in the same way that repositories are built. But that's
I believe that Swift 5.10, right, already supports at least partially restoring the caches.
If it does, then great. But yeah, it's a problem that's currently being worked on, and will continue to improve. The compiler's getting better and quicker as well with each release. So things are getting better.
So you didn't see all the comments while you were talking, but your graph attracts a lot of attention. So
very scientific
for the graph. And most people can confirm that the developers are much happier using Swift than Node.js. Someone asked about comparison with Go. It's always difficult to compare two different programming language, but you have any high-level direction?
Yeah, so first off, Go is a fantastic language. It was written for doing highly concurrent stuff from the beginning. So you have things called Go routines, which are built in right from the start, whilst Swift is kind of all-purpose, so it took a while to get there. Go and Swift should have pretty similar performance characteristics in terms of actual performance. The one thing I will say with Go, it has much better compile times, which is probably why it's used a lot at the moment. The one downside with Go is that it's garbage collected. So you don't. One of the real benefits of Swift is you get deterministic performance, which many other languages do not have. And by that I mean that you can pretty accurately predict your performance consistently because it's never going to change. So Rust is very similar, but has a lot harder barriers to entry because it's very complicated. But by that I mean that your performance is always going to be the same. Whereas with garbage collected languages like Go and Java and Kotlin, if you're using the JVM, at some point the garbage collector will kick in and your app will take like a 25% performance hit whilst it cleans up all the memory. Whereas Swift is reference counted. So as soon as that reference is gone, you take like a 0.1% performance hit throughout the whole life cycle. So it's a much easier curve to predict.
El Tintindeo asked about the difference in binary size, especially compared to Rust. I don't know if you have any data.
I don't know how big a binary file is, and it also depends on what you're comparing. So if you bundle in, so if you do like a static library compile for Swift, which bundles in all of the Swift runtime you need, your runtime is much bigger, your binary is much bigger, but then you can port it anywhere without needing Swift installed. That will improve probably significantly with new Foundation, which is the new Foundation project that's currently being worked on, because that will only link in the parts that you actually need. So if you're not doing any localization stuff, you won't link in ICU. If you're not doing any XML stuff or networking stuff, it won't link in
URL
kernel
session, right?
Yeah.
Yeah.
URL session, sorry, to be clear, because you could do networking stuff without it. So that will make your binaries much smaller as well. And again, it's a thing that will be improved over time as it gets better.
When you were talking about the different database driver, you mentioned Oracle, MongoDB. Janice added in the chat as well, Redis, MQTT, and Kafka. And Moritz asked about the state of the Kafka client. Janice, you mentioned Kafka. Do you have an idea of?
Apple is spearheading that, if I'm correct. I'm not sure what other parties are involved with the development or maintenance of that driver, but I think that's mainly an Apple or a what's it called again? Google Summer of Code project.
It's pretty active. I see pull requests and issues go across at least once a week, so it's definitely moving.
Yeah, it's definitely moving.
Worked on.
So the elephant in the room, there are two popular web frameworks in Swift, Hummingbird and Vapor. And Wojciech asked about how to decide between the two, Vapor or Hummingbird. Before you answer, I'd like to make an announcement. I want for one of the next meetup to have the same type of presentation of Hummingbird. So you will see both and you can decide which one is best for your need. But maybe you can share your point of view, Tim.
Try them. So Vapor and Hummingbird come from very similar backgrounds, but with different aims. So Vapor is very opinionated on how you should do things. It bundles in a lot of stuff to make it very easy to build your applications. Hummingbird's a lot more modular and a bit more kind of specific in the things you want to do. So if you want to do WebSockets with Vapor, it's kind of there already. With Hummingbird, you need to put in the WebSocket package. If you don't want to do WebSockets, you have to pull it in with Vapor. With Hummingbird, you don't. Hummingbird has the advantage currently in that it's basically Vapor from a few years ago, in that it's nice and new. So they've been able to build out the Swift concurrency stuff and like the actual proper Swift concurrency stuff that's just been released, whereas Vapor can't break its API just yet. And Adam and Yanis have been doing some fantastic work, like trying out those APIs and building out a new HTTP server and stuff. So Hummingbird probably has much cleaner code these days, because it doesn't have 4 years of cruft bolted on. But there's definitely space for both, so try them and see which suits your preferences.
Do you want to add a bit about the HTTP server there, or is that?
Yeah. So alongside many of the other things that are kind of seemingly lining up for Swift 6, the SSWG has been working on a few different projects to try and make it easier to share code between the ecosystems and the different libraries. So one of them is a new middleware library that's been worked on that will allow you to write middleware that will work across any framework. And this will also make it easier to write middleware that works for async HTTP client and stuff. Another project that's currently being worked on is the HTTP server. So Swift Neo is very, very low level. Vapor is very high level, and Hummingbird is quite high level as well. And there's kind of like a middle ground, and anyone writing a web framework is going to need some kind of HTTP server that's going to do HTTP1, HTTP2, gRPC, it's basically all
Middlewares.
So yeah, middlewares, responders, metrics, all that kind of stuff. So why not actually just work together and create one that works for the whole ecosystem? So I believe the HTTP server from Hummingbird 2 has been extracted, and Vapor 5 will use that as well, because it's well written. It will be pretty well battle tested and pretty modern as well.
That's a good segue to the next question about Vapor 5. So there is a stream of questions. Wojciech again, what can we expect? El Tintindeo say, when can we expect? And Peter says, why do we need Vapor 5?
So in terms of when, the aim is to release Vapor 5 around the same time or pretty soon after Swift 6 lands. So going on the Swift release cycle of past, that should be around September time. In terms of what we can expect, no more event-linked futures. That's a definite. A much cleaner API because we've got 4 years of deprecations that we can finally get rid of, and just tidy up massive amounts of code. The general gist of Vapor should be pretty much the same. Routing and stuff might change depending on, because we can now use things like macros and new features. And I've got a blog post that I've been meaning to write up. I just need to finish some other stuff first, that will talk about the plans for Vapor 5 and the kind of aims we're hitting. But the end goal is going to be the same as before. A very nice framework to use. It's easy to use for beginners and experts and all sizes. And then why do we need Vapor 5? Because Vapor 4 was written and built in a very different world. So when Vapor 4 came out, we were on Swift 5.2. Property wrappers would just become a thing and didn't really work. Async await didn't exist. Structured concurrency certainly didn't exist. And so retrofitting all of that onto Vapor 4 and things like Sendable as well have been extremely difficult. And Vapor 4's had to take some hits, I guess is the probably best way of putting it, in order to make stuff thread safe and sendable. Because Sendable and the async await world are very different conceptually from the future world. So in order for us to provide a fully structured concurrency server that's fully sendable, that works properly in the async await world without breaking the API is almost impossible. So we figured it would be a good time to do a new release. Having said that, if your code is already async await up to date, I'm not anticipating the migration to be massively complicated. Certainly not the same way that Vapor 2 to Vapor 3 was.
So that's an important information as well. Mohammed is asking if the migrations are generated automatically. I think you answered that during the demo.
Yeah, automatic migrations is something that has been asked before and we could potentially look at. I would say in my experience, they do not work and they break down very, very quickly once you get into real apps. And people start getting things out of sync.
What is the latest of using Vapor on Raspberry Pi, including the Pi Zero?
I believe it works quite well. I'm not sure about Pi Zero.
It does. We've been using it.
Okay, it works. Use it.
You showed the breakpoint in Xcode. Is it working in other IDE as well?
I know it works very well in VS Code because I spend half my time in Xcode, half my time in VS Code, and breakpoints work just as well in VS Code. I can't speak for any other language, but it's just LLDB. So if they integrate with LLDB properly, then yes, they should.
There was a discussion as well. I cannot put one single message on the screen for that, but about the dot parameter name, which is not very type safe. Is there a better way to express a parameter name while being type safe?
Yes, so you can basically write extensions for types. So you can say, what do we say? So you could have, it would be like something.count instead. Yeah, it's just a parameter key under the hood, so you can make stuff conform to it. I've done it in other projects, and it's the same with the Fluent models and stuff. Like having all these, you can define your own field keys and make sure they're not stringly typed. So yeah, there are ways around it.
And everybody, I told you, was impressed by your live coding skill. On the personal side, how are your saxophone skills?
I would say my saxophone skills are rusty. My guitar skills are much more up to date. That gets much more use than my saxophone.
How do we sign up for the Swift open source Slack? I will post a link during the rest of the conversation as soon as I can focus on something else. I will post the link here. Or if you have it, please post it in the comments. All the rest, I think, is congrats. Oh, one question. Do you have a Vapor, a dev container available to quickly get started with Vapor?
No, not currently, because the default dev container. So if you do install dev containers and dev containers, you can then do all languages in Swift. That just works fine. There is an issue on the repo for the template that I think Kemis actually created of
And I
providing.
just updated the issue just to ping you.
Yeah. So that is on our radar, and we need to do something to make it work better with databases as well. So that's all set up. But if anyone picks that up and do a pull request, feel free. Otherwise, I will get around to it at some point.
And time-wise,
I think the only real
oh,
issue
sorry.
is I think the only real issue there is the databases as well, because setting up a dev container is really easy with Swift and VS Code. Getting the right database set up is a little bit more difficult.
Mm-hmm.
Time-wise, I would like to move to the last part of this meetup and call Jim, our first speaker, but also Sven on stage. Jim and Sven, you're on mute. Sven is part of the Swift Server Working Group as well. So continue to ask us any questions you have about Swift or one of the talk that we had tonight. And I'm going to continue to go through the question because there is one which is quite generic. How can you convince a team to start to use Swift on the server?
I've done this quite a lot with speaking to engineering managers and CDOs and stuff like that. If they already have microservices, it's a very easy sell because you can say, try it because it's just a small service. It integrates well with everything else, so there's no reason why it wouldn't work. One very good entry point is using a BFF for the iOS teams. So BFF is a backend for a front end. So to quickly summarize it, most iOS apps on your homepage need to make like 40, 50 different API calls to populate the homepage. That doesn't work particularly well if you have bad network connectivity or stuff. So a BFF moves all of that to a small service that sits right next to the API, makes all those APIs so you need to make one request and you get one response. It's very easy if that BFS is maintained by the same team that writes the app because they know what they need. That team knows Swift. They should use Swift.
So it's the Trojan horse into the server-side infrastructure.
Exactly.
The backend for front
end.
end.
And then your DevOps team will be like, why is this container using so little memory but handling so many requests? We should use this everywhere.
Anyone wants to add something?
No, I think I'm in complete agreement here. I think if you're already using a microservice architecture, it's pretty easy to get started. And yeah, like if Swift as a language doesn't convince a team, if they don't see the value in that, maybe it's best to keep it for now separate, and they'll run into issues at some point that Swift may solve.
There is another question more specific to Vapor. Is the support of the gRPC? You mentioned protobuf, but
you can write gRPC servers in Vapor already. There is actually an article on Codeco about how to do that. So I'd say check that out to start with.
Maybe that's something to add to the website or like documentation then.
Yeah, we need to do a better job of that. But gRPC Swift has been around for a long time and it's pretty well used.
Very mature.
Yeah.
By the way, your answer on backend for front end caused a couple of reactions as well. So good point there. Are there best practice for long-running background task or session in modern Swift servers?
Depends a bit what kind of background task are we talking about, I guess. Like so some would classify, I mean, one perspective I could take on this is like a job queue that runs in the background. You can use Vapor queues, Mongo queue, or one of the other available queuing mechanisms that we have. There are also Redis-based queues in Swift. If we're talking about a background service that you have alongside your Vapor application or Hummingbird application within the same executable, the modern way of doing that is either using this. Well, in Hummingbird 2, you can use Swift Service Lifecycles. Swift Service Lifecycle has a service protocol that you can implement, and you can run many parallel services using a task group. All of that complexity is handled by Swift Service Lifecycle, and it automatically closes down the services that you spawn using a cancellation notification. So whenever your server is ready to be taken offline, for example, because you're doing a migration of hardware or whatever, it automatically fixes, how do you say it? Swift service lifecycle breaks down everything and sends everything the notification to close down. This happens gracefully, so if your HTTP server is still handling open connections, it won't close them right away, but it will stop accepting new requests so that things can close down gracefully. And then that happens for every service, so HTTP server or your background service alike. I'm not sure what the right solution is for Vapor right now, but I'm sure that Vapor 5 will integrate with service lifecycle. Is that the case, Tim?
Yes, Vapor 4 will also integrate with Swift Service Lifecycle.
Vapor 4.
You just need to write your own command that we are currently working on. We'll release before we release Vapor 5.
And if you deploy in the cloud, there are queues in the cloud as well, or scheduler in the cloud that can schedule your task as well. I know specifically the AWS cloud, but I'm sure the others are providing the same type of functionalities. And Rick says that he's using schedule task inside Vapor as well. Is there anything not the panel, but the question is for the attendees. We still have roughly 100 person watching this stream right now. What are the blockers for you for Swift, for adoption of Swift on the server? What are the things you would like to have? What are the things that are missing? What are the pain points? And while you are typing your answer, I'm just bringing some additional comments that are coming. Francis saying that that for long-running tasks, you can try to think about the task hierarchy inside your application and think about at which task level the long-running request should live at. And Franz continues saying that at this point in the task tree, add a task group and create a child task for the long-running work.
If you're curious about task groups and some more advanced structured concurrency topics in general, I wrote an article about that you can maybe link.
Yeah, if I can find it, yes.
It's actually a two-parter. The first one goes into the business logic of Swift structured concurrency, and namely the structured bit of concurrency, and the second article goes into state management.
I'm searching for the link, or if you can send it to me.
I'll send it to you in the meantime.
Perfect. Question from Andrew: is there any good image editing framework available?
There's a C library called
libgd.
Yeah, maybe that one. The integrator.
There's the Swift package index.
Mm-hmm.
There you go.
Right. We should have asked you. So, do you want to say a bit about Swift package index here?
Yeah, I can't think of an image editing framework directly, but what I often do. So I'm Sven. I am working on the Swift package index together with Dave Werver, and that's the place I go to find packages that I'm looking for my project. We support a couple of additional search query terms to make that easier. Like if you are looking for a specific platform, but effectively it's a search box. swiftpackageindex.com where you put in like image editing and then hit return, look at the results, perhaps tweak it a bit, and look through what you get. There's lots of stuff there. Tim mentioned earlier that the ecosystem is well provisioned with interesting packages. There should be something covering all the bases, really. It sometimes takes a bit of digging to find what you're looking for, because it's really hard to search for specific things, but give it a go.
Thank you, Sven. YRC continues the question about long-running tasks, saying he was probably speaking of some long-running jobs that need to outlive the initial HTTP request span. This is what Johannes said, what I said. You can post a message in a queue, for example, and have a runner picking up the message from the queue and run separately from the lifecycle of the HTTP request. Lisa Ann is asking if we can run Swift code on another platform using Swift Dev Container. like running Swift on Windows from a Linux device?
So
go ahead.
So dev container is basically a way of running your VS Code inside a.
Oops, we lost the sound.
Docker.
Yeah.
So you can run.
You're back. That's good.
Yeah.
Oh,
we lost you for a second.
Okay, cool.
The sound.
I'll start again. So the dev container is essentially a way of running your VS Code instance and code and all that kind of stuff inside a Docker container. So if you can run the platform inside Docker on your host machine that you want, then it works. So on Mac, you can run your code inside a Linux environment very simply. Windows does support Docker, but I believe you need Windows hosts rather than Linux hosts, so I don't think that will work. But you can run Linux hosts on Windows. So that's one way. If you're talking about different architectures, it's not particularly great for that because you've got to emulate the whole thing.
It still works, but there are definitely some performance implications there.
It's not related to dev container, but something I'm using quite a lot to develop on Linux is just to start a SSH session from Visual Studio Code. So you can have Visual Studio Code connecting over SSH to a remote machine and then behave just like if it was a local machine. So you compile, you edit your code, and you use the graphical user interface on the remote host from Visual Studio Code.
Speaking of which, if you have a Windows machine, you can remote into that. Just like you can, your dev container is kind of like a remote machine that you're developing into. You can also run Windows. You can also run VS Code with Swift on Windows without a container, and then you can remote from your Mac into that Windows machine so that you can use your Windows development environment as if it was on your Mac. Of course, if you're building GUI applications, you'll still want to have physical access to the or remote, like a remote desktop into your Windows machine to see the GUI application. But then if you're running a Vapor server on Windows, this is definitely possible with a remote VS Code.
And that's what Sean is saying as well, that they run their Linux-based Swift service from our Mac via dev containers as well.
Right.
I'd say
via Codespace.
Yeah, Codespaces are great. So that's basically dev containers on GitHub's infrastructure running in your browser. So I've done a lot of coding on the iPad using this. So I have my iPad, I just launch a Codespace, and then you have a full environment that you can run and work in.
To the question about what can we improve for Swift on the server side, there were a couple of +1 on this message from Maddie as well. Good formatting tool, something like Swift format in Visual Studio Code, something as good as in Xcode.
So I believe Visual Studio Code already supports or integrates with Swift format, the Apple Swift format, and it has an option to, it even has a couple options to disable it for or only enable it for Swift packages, or there are some various configuration options there. There's also a VS Code plugin that integrates with both Swift formatters, the Nick Lockwood and the Apple one. Yeah.
And there is an integration in the Swift 6 toolchain as well. So you can already download and test the toolchain to test that integration today. What else? This is not a question, that was just a comment. Coding on the iPad would be awesome. And maybe a last one, because I'm keeping an eye on the time as well. Any thoughts on HTMX with Vapor?
Extremely easy to get working from what I've seen. I've done a quick project, nothing serious, just to see if it was if I could get it working, but it was very trivial. I didn't make a package out of it. I can definitely help someone get up and running with the existing code that I have, if they want to make their own package.
Thank you. Thank you, everybody, for watching this very first Swift server meetup. As I said at the beginning, we are going to try to have this type of setup every quarter. So expect the next one end of June or beginning of July. We don't have a firm date yet, but we are going to continue to communicate on the same channel, the Slack, the forum, the social networks, Discord, and others. Thank you, Jim, and team or speaker for tonight. Thank you, Sven, for attending as well. And thank you to all of you and all your comments and questions and answering to each other. I like to see this community so vibrant and exchanging so much information. So thank you, everybody.
If anyone of the public here is interested in speaking on the next meetup, we already have a Hummingbird talk lined up for one talk, but there's still a second slot open for the community.
Yes, let us know if it is a professional project, a hobby project, a library, something you're working on, which is related to Swift on the server. Please come to anyone from the on the Swift server working group, and we'll host you in one of these meetup. Have a good rest of the day, good evening, good night, depending on where you are on this planet, and see you soon.
Thank you.
Bye-bye.